Hi everybody, back again. I think day 4 of doing this, and we're through chapter 12 again, and then going to introduce, or not introduce, remember this is all review, so these things should be, as we talk about them, you say, oh yeah, I remember that, oh yeah, I remember that, and blah, blah, blah. And hopefully that is happening. So get in chapter 12 with just, without the equations, look at the graphs, and then from the graphs do analysis right away. So we did this yesterday quite a bit after we graphed, so this should not be a big deal. For a parabola that is not tied to a real world problem, the domain, what can I plug in for x? Well, this graph goes out forever and down forever. So always not tied to a real world question. The domain, what is x, or what can I plug in for x, is all real numbers. Range is always a little unique for parabolas. And this looks similar to a graph we might have had yesterday, maybe accidentally, not sure, but no, never mind. It's a little different range. This goes up to 9. So the range is these y values are covered from down here all the way up to 9. Down here is negative infinity, up to 9 with a bracket, because 9 is part of the range itself, as you can see as the vertex there. All right, so what's the y-intercept? Well, the y-intercept is what crosses the y-axis. And again, remember what we talked about. That will show itself real good in standard form. We're not going to talk about standard form. We can see we have two nifty little questions down here about the other two forms because of what's given. But at least we would know this. Y equals some ax squared plus some bx. We wouldn't know that number unless we did some math. But it definitely would say plus 8 at the end in standard form. So just do be aware of that. All right, the zeros are actually the x-intercepts. So the zeros are negative 2 and 4, but I'm going to write them as x-intercepts, just so you know that there's a tie between zeros, x-intercepts, roots. Know these terms in case they were asked on your final exam. They're all similar, synonyms, if you will. Yet again, what's that yellow doing? It's increasing. So increasing, what is the interval? You name the x's that create the increasing y behavior. That's how you remember that. You plug in negative infinity for x all the way up to 1 for x. And you put a parenthesis on that just because at 1 it's actually constant for a millisecond, and then it starts decreasing after 1. At least that's what I believe the idea is. Decreases, the y's decrease when you plug in 1 for x to infinity. So it's kind of like what is happening? That's the y coordinate. What is the maximum? Yeah, I'm going to go to that right now. What is the maximum has to do with the vertex. Wow, brain. So what is the maximum is 9. Where is the maximum? That is the x coordinate. Well, that's the same thing here. The increasing behavior is what is increasing the y's. Where does it increase? The x's. So it's kind of like tied into that, how you answer that. So hopefully that helps a little bit. And then this is x equals 1 for the axis of symmetry, so just be aware of that. So now, I added these two questions, which is kind of a reverse of yesterday. Yesterday you had the equation, and then you graphed it, and then we answered these questions. Well, now I give you a picture, we answer the questions. What would be viable equations for this? First of all, we should know a is negative because it goes down. In this particular case, a is equal to negative 1 because I can just see some coordinates that match this. But what would this equation be in vertex form? Well, that requires that you know this. Vertex form is a times the quantity. We did this yesterday, x minus h squared plus k. And then you fill in the missing parts. Well, I gave you a because, you just need to know that. It'd be tough to kind of find it. We could do some other stuff. I'm not going to get into it. What you should know is how to fill in these, and that's really the key idea. So if 1 is the x-coordinate of the vertex, then it's x minus 1. Talked about this yesterday, and also the reason is, when I plug in 1, 1 for x, 1 minus 1 is 0. So it's the 0 of this set of parentheses that ends up being the x-coordinate of the vertex. And then plus 9, okay, plus k. The The vertex is 1 comma 9, so 9 goes in this position. So from this picture, you should be very easy be able to come up with the vertex form of this equation. And then that's what I talked about yesterday with that great node examples that Miss Lang made up, where we had 3 different forms, but all 3 forms ended up being the same graph. Well, that can happen. I can express this graph in actually 3 different ways. We could do some more math to figure out what A and B are. We're not. But intercept forms staring you in the face, because those are the x-intercepts. Remember, for intercept form, by the way, A is -1 again. If we have -2 as an x-intercept, then that is a factor of x plus 2. The reason why is -2 in for x turns this into 0. That's why they're called zeros. All right? And then it would be x minus 4. So these 2 graphs make the exact same, these 2 equations make the exact same graph. So just by looking at the picture and pulling out the important parts, that's actually an easy thing to do if you know the the forms. Okay, so I want you to do that. Remember, I do, you do. Actually, I added to 9, made it 10, 11. So 1 through 11 on this next part's for your homework there. And I pulled actually something from an old quiz or test and left it multiple choice. So that's your homework. Won't take long. And I didn't have a second example of this, so what I'm going to do is kind of just talk about a couple things and then ask you to think about it and do your homework by doing the rest of the questions I don't do. But you got to remember this formula. I'm going to spend a minute on this. This formula, this is gravity of Earth plugged into a formula there. Actually, gravity affects us by -32 feet per second. So this is that gravity effect divided by 2 times t squared. Don't have to know that. Just thought you'd have fun listening to that. So this is the initial velocity of the object being thrown. So we throw a football straight up in the air at 50 feet per second. And then this is the initial height that you actually throw that from. We have a tall person, 6 feet tall, that throws this ball up in the air, so it starts at that position. All right, so what does t represent? The domain. So t is time. That is how much time the ball is in the air. What is the range? So t is the x-axis. The range is the y-axis, and that represents how high the ball is in the air at a particular time. All right, so I figured I'd fill that out so you understand this equation and how it's graphed and what it means in the graph. I think you can handle the rest of this stuff. Of course, we'll cover the answers when you come back after you do your homework, but try to analyze those. All right, and then do focus on this. Oh, I forgot something. I got to change this, so I'll be right back. Never mind, I got confused in my old age again. But 6 and 7 are great. I'm not going to answer them for you, but look at this. It's not domain of the graph, it's domain of the problem. Okay, so domain of the problem. Remember, it's not domain of the graph. So we said domain is seconds, so I think we should be able to figure out what that means, the domain of this actual real-world situation. Same thing, range of this real-world situation. Figuring that, and then we'll talk about that when we get back to class.